Unit 3, Rigid Transformations, question number 2. So we're going to start off with a review. So the review says if the figure below is translated right 2 units and then 180 degree clockwise, what is the coordinate of the image point R after the transformation? So R's coordinate is 1, 5. So that would be our original coordinate, okay? Is 1, 5. So the first thing we need to do is that we need to translate, okay? So whenever we're doing translations or whenever we're translating, we're either going left or right or up or down, okay? When it's left or right, you're talking about the X. When it's up or down, you're talking about the Y, okay? So in this case, because it says we're going to the right 2 units, moving to the right 2 units, you're getting more positive. So I would add 2 to my X. So that would be, again, this was right 2. Okay, so then this would be 3, 5. And then after that, we did a 180 degree clockwise. Okay, so when I do that, I'm essentially, so again, I moved it to the right 2 times. When I'm doing a 180 degree clockwise, all right, that's a rotation. A rotation means that I'm going to be going to the different quadrants. So I'll be going into this quadrant. So to move from a quadrant to a quadrant, that's a 90 degree movement. To move to the next quadrant, that's 180. This would be 270, and back here is 360. And again, a clock goes like this. So when you're going clockwise, you're going this direction. So 180 means I'm over here. So if you look at the coordinates of any points over here, they're both negative for the X, and then it will be negative for the Y. So whenever we're doing counterclockwise 180 degrees, all I need to do is change the signs for each of my terms. Okay? So this would be the result. Okay? So let's try the next one. So the next one, we're reflecting over the y-axis and then the translate 4 units. What is the coordinate of the image point Q? So Q's coordinate is -7 and -8. Okay? So first you need to reflect over the y. So this is the y-axis. So whenever you're reflecting, okay, you're essentially going to go ahead. Oh, so let me label some things first. This is the new. Okay, so first let's label the original. So original is -7, -8. Okay, and then as I said, guys, we're gonna first reflect. So reflect over the y means that you're using y as a mirror and you're flipping it to the other side. So again, it will be looking like this, facing the other direction. So essentially, whenever you're flipping that point Q, they'll have the same y value but different x values because you're flipping it to the other side where the x is positive. So this point, -7, -8, will become +7 and -8. Okay, this point right here, -1, -9 will become +1, -9. This will become, so -1, -8 will be +1, -8. -5, -1 will be +5, -1. Okay, and that's what my, so 1, 2, 3, 4. So that's what my points will look like. And again, you can just always graph it. Sometimes graphing will take a little bit of time, but again, you can see it a lot clearly if you graph it. So if I graphed it, it looks a lot clearer. Okay, and if you realize when you look at every single point, whenever reflected, all that happens is that the y value stays the same and the x value changes. So this point right here, which is -1, -9, turns to +1, -9. Okay, so then we're gonna try to translate the 4 units. So reflect. So reflect over y, and we got the same y value, different x value, so 7, -8. And then we're going to go ahead and do a translation up 4 units. So up means you're changing y, so I would be adding 4 to y, because going up means you're adding. So again, this was up 4. Okay, so when I calculate this, I will get 7, -4. And you could see that because that's what this point is right here. This would be the Q up 1, 2, 3, 4. the coordinate would be 7, -4. So again, guys, you can go ahead and graph it if you like, okay, but that's what it will look like. So let's try the next one. So the next one, it says the figure below is dilated, then the center of dilation of the origin on a scale of a sake factor of 1/2, then translated 4 units. So where original point for W is -4, -8. So that's the original. So again, -4, -8. And then we're doing a dilation. So dilation means that you're shrinking or expanding. Okay, so essentially when I'm doing that dilation by 1/2, I'm shrinking by 1/2. So what I'm going to do is I'm going to divide each term by 2 or multiply by 1/2. So dilate by 1/2. So if I cut each of these in 2, I'll get -2, -4. Then I will go left 4 units. So that means I change the x value by subtracting 4. Okay, so I get -6, -4. Okay, so let's try to do the next one. Okay, so the next one, we're dilating by 1/4 and then rotating 180. The original point was -8, -8. So if our original is -8, -8, and then we dilate by 1/4, it means that we're dividing by 4. So dilate by 1/4. So I will get -2, -2. Okay, so what I'm going to do now, guys, I'm going to go ahead and do the 180-degree clockwise. So clockwise means I'm counterclockwise, so that means I'm moving the opposite direction. So I'll go over here, so both those numbers will actually end up being positive numbers. Okay, so 180-degree counterclockwise would give me +2, +2. Okay, so again, guys, just like that. So let's dive into the actual lesson. Okay, so the lesson wants to do the same transformations, but we're doing translation, rotation, or reflection. So in this one, we're doing from figure B is the result once you transform on figure A. So we're trying to go from A to B. Okay, so B is the result. Okay, so we're going from A to B. Which transformation would accomplish this? So if you realize, it seems like A to B would be a flip. Okay, so it would be reflecting over the y-axis. Okay, no rotations, because again, it's not changing orientation. All right, it just looks like a flip or a mirror of the same thing. Okay, so let's look at the next one. So the next one, we're trying to look for the figure Q. Okay, that's the result after transforming on P. So we're going from P to Q. Okay, so what we need to do is, so P is going to go to Q. So I would have to move. So they look like the same orientation. It's just that there's a little bit lower and across. So I'll go to the left 1, 2 units. So we translate left 2 units, and then translate again down 1 unit. Okay, so that's it. So let's look at the next one. So we're going to go from figure G to, or rather, from figure F to figure G. So it says FG is the result. So this will give us this as a result. So we're doing F to G. So here, it looks like the orientation is switched, because this pointed side right here is facing more across, and it's now facing downwards. So it won't be a reflection, it'll actually be a rotation. So this rotated. Okay, it went from one quadrant to the other quadrant. So we're going from F to G. So we're going from here to here. So we'll go from one quadrant to the other. So that's a 90-degree movement. So I'll be moving 90 degrees. So again, clock goes like this. So if this is going here, that's clockwise. Okay, or I could go from here around here. So I could go 90, 180, 270 degrees. So or rotate 270 degrees, and that would be counterclockwise. Okay, so again guys, just like that. Okay, so let's try the next two. I'm going to pause my camera while you guys try the next two real quickly and then check your answers. So these will be the answer. So again, reflect, so this from A to B, reflect over the X. This is from D to E, so translate up 2 units, right 1 unit. And then finally, this would be from I to J, so that would be rotate 90 degrees counterclockwise, or rotate 270 degrees clockwise. Okay, and guys, you can always test these by just utilizing the theorems that we know. Okay, so you could pick a point. So for example, the point right here is -4, 3. If we do a 90 degree rotate, that means that we change the we swap the x and the y, and we make the y, if we're doing counter, we make the y negative. So we swap the x and the y, 3, -4, and we make that y value negative. So it would be -3, -4. So if I look at this point, -3, -4 would be the same point right here. Okay. So again, you can always use that method to check it, guys. So similar here, I could pick a coordinate. So I'm going from D to E. So this point is the same point as this point. This coordinate is 3, -5. So, and then I translated up 2 units. So that means I was adding 2 to my y and then adding 1 to my x. So that would be 4, -3. So this point should be coordinate +4, -3. Okay. So again guys, it works for all of them. So here, reflect over the x means that they keep the same y value. They keep the same x value, but they change y values. So like this coordinate right here, -3, 2, it would be the same coordinate right here. So again, if I reflect, I would just change the y value and not the x. So this would be -3, -2. So change the sign. So -3, -2. Okay, so again, that same method works for all of these. So again, similar for the y, they keep the same y, but they have different x's. So this point right here, -5, 5 became +5, 5, because again, you change the x and then keep the y, because they're on the same line for the y. Okay, so it works for all of them if you ever want to test it with the mathematical rules that you see on this cheat sheet right here. Okay. So again guys, just like that.